Thanks. Welcome to the Mi5 Teardown. We're doing things, we're trying to become more sophisticated in what we do here today, so you'll notice that we have better tools. We also have a better way for everybody to experience. We are recording this video. It's a 720p recording, so not the highest imaginable quality, but it's pretty good, and we'll give it to you right after if you want. So we'll start with this device right here. So it's a fresh new Mi5. And the first thing I'm going to do is, using this pretty sophisticated tool here, I'm going to take out the back. So you may be familiar with this from the Mi 4. So here it is. Now, here's what I'm going to do. I'm going to zoom in. Oh, I'm going to show our tools first of all. Oops. So this is a pretty awesome screwdriver set. There's all the different bits in here. This is micro USB, so you just this is charging. You just connect it to micro USB power and charges. It's a pretty cool electric screwdriver. And this over here is a magnetic pad, so I can rest my screws pretty comfortably somewhere. All right. So to start, I want to point out a couple of things here. Sub PCB, battery, main PCB, and the first thing I want to show is this here. So do you guys have any idea what this is?
Antenna?
Yep. Well, that's the LDS antenna. It means it's short for laser directed structuring. Basically what it does is you sensitize the plastic surface with laser, and then you apply like a metallic paint, which basically adheres to the plastic in the area that was sensitized by the laser. At least at the end of the process, that's what results. So this is the main cellular antenna here, and then you have two other antennas for GPS and Bluetooth Wi-Fi. And we also use a diversity antenna approach to this device, which is we actually use the outer metal frame of the device to also help with the antenna. And when you see this detail here on the end, this has to do with the fact that you're essentially splitting the outer metal frame into a couple of different parts so that you can use it for different antennas. What's interesting is that only one of these is actually real, and I think it's this one. The other one is just there for symmetry, but it actually isn't separating the different parts of the metal. So you actually have two, basically two antennas that you can use as your secondary antenna, if you will, but the primary is what you see here internally. All right, so I'm going to start by taking out the sub PCB here. So let's get started. And John, CJ, please feel free to chime in. Sounds like we're in a dentist.
And thanks for grouping all the screws together neatly. It helped a lot when I reassembled.
There you go. Yeah, this
is actually interesting because each color corresponds to different.
Yeah, we have this three different colors of screws. Actually, there's four. There's one special screw that I'll show you guys in a second. Huh? Say again? And then this is the warranty seal right here. Once this is broken, we'll know that you've got into the phone. So just keep that in mind. All right, so I'm gonna go ahead and pry this open right here. Take it out. So the cover of the sub PCB has another feature besides the antenna, which is the speaker box, which is this guy right here. So the speaker box basically it's got a speaker inside, but it also has to have some room, some empty space, basically because audio, as you know, sound are mechanical waves, right? So you can't generate it from no space at all. That's why a lot of real speakers have actually a lot of empty room inside, because they need that to basically like suck in air and then push it out through the actual speaker. So that's the speaker opening right here, and there's a little gasket thing here that actually it's a very low tech trick. It's just basically a piece of foam that is just there to try to absorb excessive vibration to reduce distortion. And if I were to open up this speaker box, this is what it would look like right here. This is basically this piece here, opened up. So that's basically the actual speaker right there, and this is essentially like a powdery foam area that's pretty much empty.
The cross is the natural.
It's in here.
Okay.
Yeah, it's in here. And this is just like a foamy area that's used to create sort of dampened vibration, if you will, which then sort of comes out through this opening here. Anyway, so that's the speaker box. Over here we have the USB Type-C port. And as you can see, obviously the opening, as with any Type-C port especially, is pretty large. It's actually a pretty big hole in there, which is very, very susceptible to water, right? Whether it's flooding water or even just ambient water. So this particular component of the phone is IP67, IP67 water resistant, right? Meaning it'll be hard for water to get past in here if it's not a lot of water. That's just this component, to be clear. And then right behind it here is a water detector, right? So if water gets into the phone, this thing is going to change color and will know. A few other things here. I'll get to the fingerprint sensor later, which is behind. Any idea as to what this is? This guy here?
Looks like a tiny thing.
It does, but it's not. So this is the vibrator. Yeah, it's the vibrator motor. And it's a special kind of vibrator. It's a linear vibrator as opposed to a rotational vibrator, which is what normally we have in phones. And this is because of the extremely limited amount of space that we have here.
So it moves backward and forward instead of rotating.
Exactly right. Exactly right. So it's vibrating essentially. It's vibrating in this direction here, right? So if the phone is in your pocket, you're more likely to feel something that's sort of micro hitting against your body than something that's just kind of vibrating internally. But I'll take this guy out. It's actually a pretty large component, relatively speaking. I'm just disconnecting it. A little glue here, so I've got to kind of force it out a little bit. Try this tool. There it is. Yeah, so there it is. It does look like a battery, but it's actually a tiny little motor. It's actually fairly big. It's a pretty big piece relative to everything else. So that's the linear vibrator. Okay, so then what you'll see here is these 3 pins. These are the pins that connect to the antenna on the sub-PCB, and they also connect to the diversity antenna on the bottom, which is the metal frame. And then there's a track in here. It's in between the 2 sandwich layers, and that connects to this cable, which is what links up to the rest of the device here. I'm not going to disconnect it yet because the battery is still connected. I have to open the main PCB before I can take it out. Huh? Yeah, I'll do that later once I take this out. Yeah. Can I have the removal tool when you get a chance?
Yeah,
oh, there it is. Okay, so let's take out the SIM card here. Okay, so that's out. Alright, so I'm going to take out the... Oh, before I do that, a couple things I want to show you. So this is the back cover, which is Gorilla Glass floor glass. It's actually very, very light. And on the inside, you'll see this film. Any guesses as to what this is?
The heat product? Heat film?
Yeah, this is the heat film. So this is for heat dissipation. So to equalize the heat dissipation as much as possible across the device. And then, any ideas what this here is? Any idea? I'll show it. It looks like if I peel it off a little bit.
Well, that's the NFC?
Yep, that's right. It looks like an RFID tag, right? So that's the NFC antenna. Right? It's basically a sticker on top of the main PCB cover. We try to do as much as we can with the little space that we have here. So I'm going to go ahead and take this out now.
Wow. Yeah.
I also have a light here.
That's what the wool is for.
Oh.
Oh, I see. Mom and wow. Uh-huh. Okay, I've got one more here. And then, so we're almost done here. I'm gonna move this back. Then over here, this is obviously the rear camera, and I'll tell you about why this this part of the cover is metallic in a second. But then there's a screwdriver. There's a screw here, which looks like a metallic screw, but I actually can't pick it up because it's actually not a metallic screw, or at least it's non-magnetic. So I have to pick it up like this. And if you notice, when I put it over here,
It won't stick.
see, it doesn't stick compared to the other. See, this moves around pretty freely. So this is a non-magnetic screw precisely because it's sitting right next to the camera. And if it were magnetizable, it could potentially interfere with the OIS functionality, which we'll talk about in a second. So I thought that was pretty cool. All right, so I will now. Oh, there's one left. I always forget that's an actual screw. Thanks, John. Okay, more warranty for you guys in this one. Okay, go ahead and take this up. Pretty neat. Okay, let me just take a look at this for a second with you guys. So obviously the plastic piece. What you notice is how thin this part here where the camera cover is, how thin that is relative to the rest of the frame. Can you see the difference? It's like a small foil almost. It's so thin. And this is because we needed we wanted to make the device as thin as possible. The module, the camera module, is essentially what determines the thickness of the device, right? And you'll see how big this module actually is. So by making the cover to the module as thin as possible, we essentially gained ourselves maybe another fraction of a millimeter in thickness. If we were using the same, if it was plastic all along, you see how much thicker it would be. That would make the whole device thicker, right? So a small detail that actually costs, right? Because you're all of a sudden not just making a single plastic molded piece, but you actually have to attach this guy over here. So I think that's a pretty cool detail as well. All right. So first thing I'm going to do here is disconnect the battery. That's this guy right there. And if you guys saw that video of a printing press massacring a phone, that was just viral a couple days ago. And I don't know if you noticed the size of the explosion that thing caused. It's all because of the battery, right? So we have to be very careful with the battery. So now that the battery is disconnected, we can do other things here. So first thing I'm going to do is I'm going to disconnect the RF cable, which is this guy right here. I was showing you earlier. It basically runs all the way down to the sub PCB. Okay, that's disconnected now. So it runs all the way down here through these connectors, it connects to the antenna, which is on top, like I told you earlier, right there. Okay. Now I'm going to disconnect these two connectors here as well. This runs all the way down to the sub PCB, so it's the USB connector for obviously charging as well as data transfer, the fingerprint sensor, and the speaker primarily. So I'm going to disconnect this guy. And then this one over here is for the display, which we'll talk about in a second. So that's disconnected as well. So what I'll do now, before I take out the PCBs, I'm going to take out the battery. So for that I'm going to, so this is pretty cool. So the battery is actually glued to the device. As you guys, some of you remember from last time. I'm going to do a better job this time. So it's glued to the device using these like glue sticks that are one directional glue. But when you so when you try to pull out the battery like this, it basically won't let it come out. It sticks it pretty hard. But if you try to pull the glue out, it actually works beautifully. So you see that? So it's actually underneath the battery. It goes underneath the battery. I'm going to pull that out before I do the zoom out. Okay, so check this out.
Gotta stretch it out. Who's practice with that?
Better, right?
Yeah.
Okay. So that's one. I'll remove the other one now. Getting good at this.
Yeah. You can tell from his face he enjoys.
The same face when you do bubble wrap.
Yes, yes. Oh, I'm obsessed.
Nice. And of course with that, the battery is now loose, so it'll come out pretty easily. I just gotta pop it out. No problem. Look, she's in last time, huh? So that's the battery. Guys want to take a look around. So it's 3,000 milliamp hours, typical, 2910 minimum. Okay, so now I can take out the PCB. I just have to take out one more screw, which is this guy right here. I've got to disconnect this one other connector here. That was for the side buttons. And oh, that guy. See, that's for the proc sensor. And with that. Actually, I think the proc sensor would have come with it.
Yes. Easier.
Yeah. So, aside for a bit. Okay. So this is the bottom side of the PCB, and what you have here. This is the critical area. You guess what's going to be in here?
The 820.
The 820 is in here, but it's actually not at the top, and I'll talk about that in a second. But this is the area that, of course, gets really hot because that's where the chipset is. So this is good old thermal paste. In fact, slightly toxic, so we're not going to play around with it too much. Over here are the power amplifiers, and what we've got on the top of the power amplifiers is two electrical isolating and heat dissipating things. One is this foamy thing here. It's actually pretty fluffy. So it has both a heat dissipation as well as a physical protection capability, because this component is very, very sensitive. So take that out, and that's just thermal paste right there. If we were to scratch away that thermal paste, basically this is what it looks like. And so without the thermal paste on both components, I've also taken out some of the shield that you see here. These shields are to protect from electromagnetic interference. I'll just move that aside for now so you can take a look at this guy instead. Zoom in a little bit further. So this is the same PCB except we've stripped away the shields and removed the thermal paste. So what you see over here, this is not actually the chipset. This is RAM. The thing about these processors these days is that they're so fast that the distance between the chipset and the memory actually can affect performance of any computation. So the closest possible setup that you can have is for them to essentially be together. So the memory is actually soldered on top of the chipset. So the connections between essentially the wires connecting the two are as short as possible. And that's, by the way, that's not a trick that we do. This is standard in the industry these days. You'll have a hard time, you'll be disappointed that you can't find the chipset, but it's because it's in there. A few things here. Here's the infrared port. It's very small compared to the size of my finger. It's my pinky. It's a very small infrared port. That's the front camera, and so on. And then on the other side, the PCB you've got over here, also stripped away from all of the various different shields. If you look here, this area right here in particular contains a lot of RF components, so it's very important for it to be electromagnetically shielded. And when you take out the shield, this is what it looks like. So all these various different components. A lot of the work that we've done on Mi 5 that's new is in this area, with a lot of the new LTE bands that we support. You have to add components, basically various different microcircuits for each band that you support. So it all goes in this area over here. What else? Yeah, and I guess I'll just take the fresh PCB here. One thing that I love doing is I've got to take out the cover. Okay, actually, so what I was going to do next, I'll just move over to the other PCB, is take out this cover here. So this right here is the sapphire glass on top of the camera module, and then it's just another cover for it, which when stripped away it looks like this. So it leaves the sensor relatively exposed, and I can play around with it. You saw this in the video, so you can see how loose this thing actually is. You can actually move it up and down, or you can move it from side to side. And this is how OIS works. It's actually, the camera actually moves a lot. It's like a pretty significant displacement. And you can actually see it moving when the camera is operating. It's pretty awesome. Sorry, John, I advanced the tweezers a little bit. So anyway, so this is what the PCB looks like. I'm not going to go into too much more detail here. Oh, there's couple of other points here. This is another water detector, and I think there may be one on the other side as well. Yeah, it's right there. Just so that we keep an eye on water damage. That's very important for warranty. Any questions so far? Okay. So the most expensive component of this phone is without a doubt the chipset, but the second most expensive component is actually the display. I'm not going to take out this frame here to try to get to the display. Instead, what I'll do is I'll show you a fresh display. But before doing that, let me actually just show you the fingerprint sensor in here. Oops, wrong direction. So the fingerprint sensor, you can see just a little bit of it here. It's actually just over there. You can hear the clicky. It's a pretty intuitive shape. So the fingerprint sensor is back there, and over here, you can't quite see it unless I turn it around like this. Over here is the fingerprint, right there. That's the controller for the fingerprint sensor. Just in there. Anyways, so what I'll do now is I am going to, is it this one?
Yeah.
So I'm going to show you what the display looks like. So the display is the second most expensive component on the device. Push these guys away for a bit. And this is what it looks like. So the Gorilla Glass 4 on top, you can look at that's maybe about 0.8 millimeters thick. And then the other component, which is essentially this, what looks like a white piece here, that's 1.1 millimeters. What's interesting is that 1.1 millimeters has 12 different layers. It's like a mega sandwich that forms the display.
Is that the light guide?
It's got two main components. It's the backlight unit and then the LCD itself. And I want to show you, I'm going to deconstruct some of this guy for you guys. The first thing that you see here is this awesome thing, which is just a reflector. Of course, this one a bit scratched up on this side. I'll show you what it looks like on the other side. This is a very important component. It essentially has to be as close to a perfect mirror as possible, because any light that bounces to the back of the phone has to basically come back. So I'm going to peel that off. And especially on this side where it hasn't been scratched yet, you can see that it really is like a perfect mirror of sorts. And take that out like a checkbook. It's actually pretty beautiful. So this is made by 3M. This is the highest quality reflector. That's not reflector, it's called something else. The name is, yeah, it is a reflector. Basically any light that decides to go into the phone just hits on this, and because it's pretty much a perfect mirror, it comes back. I can pass it around if you want. So that's the back of the backlight unit. The next component here is very critical. It's the light guide. But before I talk about the light guide, let me go a little bit closer here and take a look at the LEDs. So you saw a picture of this briefly on the PPT yesterday, on the presentation that we did. To make sure that we're counting things right here, 4, 8, 12, 16. Right, so there's 16 LEDs here exactly. And I think, as you can quickly tell, if we had less than 16 LEDs, we would be able to comfortably fit them into a smaller display. We wanted to get them as close as possible, and we increased the size of the display a little bit so that it would accommodate the 16 LEDs. By the way, they're closer to each other than it would normally happen. To get them this close, we had to work very closely with the LED manufacturer themselves to make sure that these individual LEDs did not affect their neighbors when they got a little bit warm. So there's quite a bit of work that went into making this a 16 LED array. And this is potentially one of the biggest engineering breakthroughs of the display. As simple as this might look, this is actually pretty awesome. This array is a pretty awesome thing. So those are the LEDs. By the way, on this end here, you have the display controller, which I'll talk about in a second. So zoom out a little bit. Now this thing looks a little bit like these visors that kids use to like kind of distort the world. You just kind of hold it up. I don't know if you know what I'm talking about. I'm going to try to peel this off. This is the thickest component of the display. I'll first take out this border here. By the way, this is one of the reasons why you can't have a borderless display, because you kind of need this. Take that out. On the side. And I'm going to try to peel off the light guide here. Comes out pretty neatly. So a light guide, for those of you who don't know what it is, I'll explain it briefly. The checkbook thing. So the light guide has a very simple function. What happens, of course, with these LEDs, as you can see, is that they're basically pointing this way, right? So they're shooting light from the bottom of the phone towards the top of the phone. What the light guide does is it basically takes that light and forces it to go either up or down. Whatever goes up, of course, just keeps going up. Sorry, up is actually that way, right? That way. So whatever is going up, keeps going up, and that's going towards the outside of the phone. That's where you want it to go. Whatever comes back will hit the reflector and then immediately turn around and go back out. This technology was this is essential, this is a total reflection. It's like basic physics, right? Total reflection, total reflection, or total refraction. And which did it just go off?
Oh, it's half an hour limit, so you got start.
Oh, I see.
Yeah.
Yeah, so basically it traps the light in until it hits the surface at an angle where it's allowed to go out. It's the same technology that the Kindle Paperlight uses. That's when it got talked about a lot, but that technology actually comes from mobile phone displays. But this basically, this piece is very, very key. This is also a very high-end component that we have. It's the thickest part of the display, so that it basically gets as much light as possible to go out. So that's the light guide. You guys can take a look at it if you want. The next layer here is very easy to peel off. This is just a diffuser, and what this does, it just tries to spread out the light a little bit more if it's concentrated, because it's coming from the LEDs, which are somewhat concentrated. So this diffuser just spreads the light a little bit more. It's very, very thin layer. It's shiny on one side, opaque on the other side. I'm not going to peel this off, don't need to. And then the other next component here, might as well. That's the diffuser. The next component here is a prism. What a prism does, anyone want to guess? What does the prism do?
Breaks the light out in different colors.
Nope, not that kind of prism. It's the same physical behavior, but what it does is slightly different.
It chooses which light to...
It makes it go straight. It straightens the light, essentially. That's what the prism does, right? So at this point, you have basically all the light coming up, because whatever went down bounced back to the reflector. It's been diffused, so spread out a little bit, but the rays of light are going in every direction. What the prism does is it basically straightens the light. Or a reverse prism, exactly, precisely right, exactly right, right? So all of this is basically a mechanism to take the light coming from the LEDs here, turning it around and make it come out, or actually go that way, in a straight line, if you will. It's not a perfect straight line, of course, which is why you can actually obviously see the display from the side, but it's sufficient, because you gotta get it to go through the LEDs first. Now I'm not going to go through the next layer, because this is where we're going to get into the LCD. In the LCD, it's not a good thing to play with it, because the liquid crystal inside is slightly toxic as well, plus you can actually get yourself cut. But essentially we're done with the backlight unit here, and the next step is the LCD, and it has a few more layers. So I'll pass this around, and this controller here, all it does is basically give different voltage to every pixel of the LCD, which decides how much each of the 3 little windows in a pixel will open: the R, the G, and the B. So I'll pass this around to you guys. Display technology is pretty awesome, because in any single one of those components by itself, with the exception of the LCD, is like pretty boring. It doesn't do anything special. But when you assemble them together, it's pretty amazing. So we were very directly involved in actually putting that together, in creating that display. We have some patents also on that display.
Why go with LCD instead?
Sure. Well, there's a few things to say about that. So first of all, AMOLED is not a standard component in the industry today. You can't go around and just buy 10 million AMOLED displays. There's only one supplier of AMOLED displays in larger quantities, and they of course also have their own uses for the display, so they use it on their products. The other suppliers in the industry are just ramping up, right? But they're not yet at a place where they can make displays in large volume. Display is one of the things that we dual source. We dual source every component of that stack, except for the reflector, which we only get from 3M, but they can make it in extremely large quantities. But the other components we dual source. Today it's not possible to dual source an AMOLED display. In fact, even single source, unless you are okay with small volumes. So that's why we can't do it yet. The other thing too is that it's more expensive. And so kind of have a choice between a very bright display, and by the way, what I would say about our IPS display is that it goes very bright, officially 600 nits, but Mashable measured it, I think it was Mashable, right? 628. Oh, it was GSM Arena. They measured 628, but it actually goes down to 0.7 nits, which is lower brightness than any AMOLED display would go. Which is amazing when you need extremely, you're in a very, very dark environment, you're in bed at night reading, it can go very, very dark as well. We actually have a feature in the OS called Night Display that does exactly that. Anyway, so that's what I would say. I want to assemble this neatly here for you guys to take photos.